Welcome back to Geometry Classroom. Today we'll talk about Euler's formula regarding edges, vertices, and faces of solids. We have two objectives for this lesson. Students will be able to count vertices, edges, and faces of solids. And students will be able to explore the relationship between the number of vertices, edges, and faces of different solids. Now, a solid or a 3D shape, right, as we know, has a few components. Has vertices, edges, and faces, right? What is a vertex? A vertex is a corner of the 3D shape, or a vertex is a point where several planes meet at a point. As we see here, at this vertex is the point of intersection between this plane, this face, and the bottom one, right? An edge is the line segment where two faces meet, right? As we can see here, this edge, is the place where this face, right, the top one, and the front one meet, right? Good. And a face is an individual flat surface, right? Like this one, right? This is a flat surface, right? Another flat surface is this one, right? So any flat surface of a solid, right, is called face. Good. Now I'll show you the different faces, vertices, and edges, right, for a few shapes. For example, this is for a rectangular prism, right? So these are edges, right? This is a flat. These are flat surfaces, and this is a vertex, right? Also for this one, right? This is for a rectangular pyramid, right? This is vertex. Face is just this flat surface, right? And edges, right? And for another shape, for a cube, right? Again, we have edge, vertex, plane surface, and so on, right? Now, for a cylinder, again, we have flat surfaces, right? The bases, which are circles, and this is an edge, right? But the edge is not straight anymore, it's curved, right? Good. Now, I'll show you different, for different shapes, what is the number of faces, edges, and vertices. For example, for a cube, we have 6 faces, 12 edges, and 8 vertices. For a rectangular prism, we have the same number of faces, edges, and vertices. For a square pyramid, we have 5 faces, 8 edges, and 5 vertices. It's not so hard to count them. All we need to do is to remember the meaning, the definition of each component. What is a vertex? What is an edge? What is a face? Yes? For And now keep in mind this detail. For sphere, cylinder, and cone, we don't have any face, any edge, any vertex, right? Because they are curved, right? Good. Now, I'll show you the Euler formula regarding edges, vertices, and faces of a polygon. Now, there is a relationship between the number of faces, edges, and vertices. And this formula is given by this relationship. And the number of faces minus the number of edges plus the number of vertices equals always 2. But we can rewrite this initial formula in this form. Yeah? In other words, the number of faces plus the number of vertices equals the number of edges plus 2 all the time. Yeah? It's not so complicated. Now, let's have two applications with Euler formula for edges, faces, and vertices. For this problem, it says find the number of vertices, faces, and edges for the figure. As we can see, this solid has only one base. The other base is reducing to a point, which means this solid is a pyramid. The name of the pyramid is given by the name of its base, which is a hexagon, right? So we deal with hexagonal pyramid. Right? Now, let's find the number of faces, the number of vertices, and the number of edges. Now, faces are all flat surfaces. And as we can see, we have 7 faces or flat surfaces, right? 7. V, which is the number of vertices, also is 7, right? In this case, the number of faces equals the number of vertices, right? Vertices are all these points, right? Faces are all flat surfaces. Now, edges. Edges are the sides, right, of the hexagonal pyramid. And we have 12 such edges, right? We count the number of sides. The base has 6 sides, plus another 6 edges for the side faces, right? So there are a total of 12 edges. Good? And the second problem, right? It says use Euler's formula to calculate how many vertices a polyhedron has if it has 12 faces and 30 edges, right? In other words, we need to find the number of vertices, right? As we know, according to the Euler formula, the number of faces, right, plus the number of vertices equals the number of edges plus 2, right? We need to find the number of vertices, right? So the number of faces is 12, right? Plus, because we don't know the number of vertices, we leave the letter as it is, right? And solve for V equals the number of edges is 30, right? Plus 2. Good? Now, we leave the left side as it is, 12 plus v equals 30 plus 2 equals 32. Then we solve for v. To solve for v, we have to subtract 12 on both sides. Yes. And we get v would be 32 minus 12 equals 20. So the number of vertices would be 20. So that's all we have for today. Thank you for watching my video.